And no, this is not a robot becomes self-aware and destroys the world. This is an industrial robot arm, so you think FANUC, ABB, MotoMan. A simulation of learning how, through machine learning, for a robot to learn how to pick from a position, go to a waypoint, and place. And again, it's starting from scratch. So the robot initially has no idea how to move at all. And eventually will figure out how to control all of its axes to get to any specific point in 3D space, which then you can move from a pick position to a place position. And like any good story, let's start at the end. This is the current state of my project right now. What it can do at this point is it can find a target in 3D space, these pink dots here. It'll go to a waypoint, and then it'll go to the drop position, and then go back to the waypoint, and then go home to find a new pick. And it will just keep doing that continuously. These are all the current robots alive in this generation. Let me blank most of those out so that we can just see one. That one's going to die. Here we go. And when you see a whole bunch of robots there, it's the way the neuro-evolutionary system works. Is you have a large pop size, you introduce a mutation, and through the genetic algorithm will evolve the network to get the desired results. So when you see a whole bunch right here and they're not all moving the same way, it's because each one has been mutated to move in a slightly different way. And then of course the targets are all in different locations too, so that's why they're not all on top of each other, they're all spread out. So you can see that in this generation they've fairly successfully been able to pick, move, drop, go home, and continue. Again, this is my what I wanted as a final result. I can show you now here kind of how I got to this point next. And this was the previous result, so this is before being able to pick and place. This is basically just the robot being able to locate its end-of-arm tooling to any point in 3D space. Here's the whole generation going at it, but it's really difficult to see what's going on. So we'll just pick one of them to look at here. And you can see it is finding its way to each target, and then a new target will be generated. So it's just going from target to target, and it's doing it rather quickly. I'll go into in a little bit why I find this so amazing. Basically, it's just because it has never been told how to move. The neural network has figured out how to take an input, basically just the difference in X, Y, and Z of the end-of-arm tooling and the target, and being able to control each axis to get the robot to the correct point. In fact, let's go now and take a look at what each axis is. Okay, so this is just the robot simulator by itself without any neural network. The keyboard right here will control each axis. So what do I mean by that? So this is axis 1, just moving about in the XZ plane. And then axis 2 will move it up in the Y plane. Axis 3 is that joint right there. Axis 4. And axis 5 just rotates the gripper. And then axis 6 is the gripper itself. Now in the program that I've made here, for the neuro-evolutionary program, I'm not using axis 6 at all. I'm just interested in getting the end-of-arm tooling to the target and then being able to have it drop over here and then go back home. So what's interesting about the neural network is that, like I've said, the inputs to the neural network are just the delta of the XYZ of this point right here, the end-of-arm tooling, and the XYZ of the target. Okay, it's not been given any trigonometric functions as to how to optimize the axes. It has not been giving any of those inputs. In fact, it doesn't even have inputs for the table itself here, which if it collides with, it'll die. So it only has those points as the inputs, and it learns how to move each axis to get that end-of-arm tooling to the proper location. So, even for a person like me trying to figure out how to get each axis to the right point, it's it's not a simple task. So how does this all work? So here the system is starting from scratch. I've just loaded the page. I haven't loaded in a pre-trained network. What it's doing now is it's randomly going to start moving some of the axes around until it will randomly bump into a target and it will get more points. Specifically, it'll start increasing its fitness function. What that fitness function will then do is then the next generation, the robots with the higher fitness function, will be able to pass on their learned behavior to the next generation. So eventually, from generation to generation to generation, it's going to slowly figure out how to move these axes and coordinate them to get that end-of-arm tooling point to the point that it wants to. So what makes this unique? I'm sure that companies like ABB, Fanuc, Motoman, I'm sure they have their own machine learning tools. But this is, like I said, this is running in a browser, and it was written in JavaScript, and it's running on a very low-powered machine. This is not a server. This is not a machine with a high-end NVIDIA graphics card. Okay, this has an integrated Intel graphics in it, and it is just a Intel Core i5, 16 gig of RAM on a very portable computer. So this is something that a robot programmer could be on the floor with, and it only takes, again, like half an hour to teach it. So this is something that would be very viable for a company or a programmer to be on the floor with. So again, this is the final result. Here you can see here's all of the robots currently left alive in this generation. It kind of becomes overwhelming, so I tend to just look at one at a time. Overall, I'm really happy with the way this turned out. The robot moves fairly much like a robot actually does. I've integrated dozens of robots over the years as a controls engineer, and that's kind of why I guess I was interested to make a project like this. I learned a great deal on this project. I really enjoyed it. One of the first things I had to figure out is how to get a neural network to find a target in 3D space. And then to do that, first I had to be able to get a target to have a neural network find a target in 2D space. So I had to actually write several programs to end up in this program. In fact, I can show you that right here. So in order to get the robot, the end-of-arm tooling to get to any point in 3D space, I needed to figure out how to get a neural network agent to get to any point in 3D space in general, not just as part of a robot. So I had to create this program, where here dots are just trying to move around in a 3D cubic space to find a target, and then once it hits it, a new target will be generated. It'll go to that one, and it'll just continue on in that manner. So I had to create this program in order to learn what I needed to do to get it to work for the robot. But to get this program to work, I also had to first figure out how to get to work in 2 dimensions. So here I created a program for just a neural network agent to figure out how to move about in 2 dimensions and find a target. So there are various tricks that I learned in here that I was able then to pass along to the 3D version, which then I was able to pass along to the robot simulation. So if you want to learn more about neuro-evolutionary systems like this, a great place to start would be Coding Train. He has a whole series of videos on neuro-evolution. Specifically, he creates a version of Flappy Birds that learns how to play itself. Or if you're learning just how to program in general, Coding Train is a great place to start. He has literally hundreds of videos on all sorts of topics. Another resource would be Code Bullet. I've watched a lot of his videos, and his videos have been an inspiration for me to take what he's done and implement it myself. And by doing that, I've learned a great deal about machine learning in general and neuroevolution specifically. I have a whole bunch of other programs that I've made leading up to this project. I'd say the Robot Simulator is sort of the culmination of what I've learned to this point. But I think maybe if this video does it all well, I can make a video on this. This is just a car track, car learning how to go around a track. And I've even got it to where you can save the neural network from this guy, plug it into a different track, and it will run perfectly. So if you all enjoyed this at all, give it a like, subscribe, and I can do that video next. Thank you very much.